Alright, let's have a quick look at this question. It goes points A to B. A and B are points on the upper and lower ends respectively of a line of the greatest slope of a plane inclined at 30 degrees horizontal. Distance AB is 20 meters. M is a point on the plane where A and B, the surface of the plane is smooth between A and M and rough between M and B. A particle is projected with a speed of 4.2 down this line of the greatest slope. P moves towards the plane, reaches B with speed 12.6. The coefficient of friction between P and the rough part is √3/6. Find the distance AM. Okay, so first of all, we've got this particle. Don't know the weight of it. I'm going to call it mg. This is the contact, and this is going down the slope. So coming down the slope is going to be mg sine 30. Okay, and up the contact force reaction is going to be mg cos 30. Okay, so that's going down. That's going to be contact. So let's just change that a bit. You know that sine 30 is a half, so that's going to be mg/2. Okay, so that's coming down here, and here from this point to here you'll get friction. So at this point, friction would equal mu times the reaction, which in this case is going to be √3/6 multiplied by, now cos 30 is √3/2, and that's mg. So if I smarten that up, that's going to be 3/6, which is a half, times 2 is a quarter. So that's going to, friction is going to be 1/4 mg. Okay, so we got that. So that's coming down here. What else have we been told? We know that the final speed here is 12.6 and the initial speed is there. Okay, is there anything I'm missing? No. Oh yeah, and this distance here we don't know, which we need to find, is called x. So this distance here will be 20 minus x. Okay, so let's set up our equations. So the first equation is this first part where it's at PA to M, and that's going to be, now this is coming down with this force, which is going to be a half mg. There's no resistance to that, it's smooth, so that's just going to be, we're using force equals mass times acceleration. So that's going to be the mass of this particle, I don't know, is m, and the acceleration is a. So straight away I can cancel these m's, and therefore I can write a as half g. So the acceleration is half g coming down there. The second part on the m to b, you're going to have, it's going to still come down with that force, which is half mg, but this time its resistance is friction. Okay, and that's going to be again ma. Now the friction here is 1/4, so you're going to get a half of mg minus a quarter mg equals ma. Now a half take away a quarter mg is going to just give me a quarter mg, which equals ma. Again, the m's will cancel, and therefore in this part the acceleration is 1/4 g. Okay, so let's have a look what we got also in this first part. In this first part we know acceleration is half a g. We know that well, we don't know it, but the displacement, we've got to call it, is x. we know the initial speed is going to be 4.2. Okay, that's what we know at the moment. What do we know here? We know that the displacement is going to be 20 take away x. But in this one, we know the final speed is going to equal 12.6. Okay, so what can we do? We can try to find the final speed here, and that final speed here, when we find it, will then end up being the initial speed here, and then we can match up some equations. So let's do that. So in the AM part, I'm going to put it AM. Okay, so it's going from there to there. Let's use that. So we got A as UV. So I'm going to use the formula V squared minus U squared equals 2AS. In fact, I'm going to use that in both parts. So that means that we don't know what V squared is, but that is going to be minus 4.2 squared, which is going to equal 2 times half a G times X. Okay, so if I bring everything to one side, V squared, the final speed when it reaches, before it reaches a rough bar, is going to be, so 4.2 squared is going to be 17.64, and that times that is a 1G times X is going to be just XG, GX. Okay, so V, the final speed, is going to be the square root of this. Okay, so now I've got that, which now this becomes an initial speed here. I'm going to put U equals this speed for this second scenario, because this will now be the point where it reaches a rough part, then starts traveling there. So U is going to be 17.64 plus xg root. And like I said, I'm going to use this for this part too. So for the part where it goes from M to B, V squared, which is going to be 12.6 squared minus all this squared. So all that squared is coming back to here. 17.64 plus xg is equal to 2. At this time, in the rough part, the acceleration is 1/4 g, and the displacement was 20 minus x. Okay, so if we square that, take that away, we're going to end up with what do we here? Let's do arrangement. So that squared, take with that. That's going to give me 141.12 equals, I'm going to take this to the other side. Okay, so that's going to give me so this ends up as a minus, then it's going to be plus on that side. Let's deal with this. That's going to be a half g times 20 minus half gx. This minus half gx is going to be a plus gx on this side, whole one. That's going to be a 10. So then I'm going to get 141.112 minus 10g, taking that to the other side, and this minus plus a whole one is going to give me half of gx. So then I'm not take with that, it's going to give me 43 0.12 divided by, take that to the side, I'll actually times that by 2, then divided by 9.8 is going to give me x, and therefore if you put that in your calculator, you'll get x to equal 8.8 meters. Just quickly check the calculations, put it through the calculator, and you got that. Okay. So the second part is find the angle between the contact force and the downward direction, of the line of the greatest slope when P is in motion between M and B. So this is M and B. So the contact force is going to go something like this, and that is going to be met by this friction, and this is the Rn which we have here. Okay, so let's find this, and then we can find the contact it makes with that. So let's just do this in a different color. So let's find this angle here. I'm going to redraw that. So that is drawn here. So if we find theta, which is going to be Rn is this, which is root 3 over 2 mg, and this is friction, which is here, so 1/4 mg, and this is opposite of adjacent, so you got tan. So tan theta is going to equal opposite root 3 over 2 mg divided by 1/4 mg. They're going to cancel, and that's going to be tan inverse of, so we got through there, that's going to be times that by 4, so that's going to be tan inverse of 2 root 3. I do that on my calculator. Tan inverse of 2 root 3 is going to give me 73.9 degrees, but that is this angle, and it wants the contact angle between the contact force and the downward slope. So it wants this angle here. So we just have to do 180 minus 73.9. So that will equal minus 180, 106.1. Okay. This one's not a bad question. This is a nice question, how it goes through there. And then just be careful. Show all the steps, you got that angle, and then this is, it wants the angle between the rough bar MB and the contact force, which is here. Okay.